It was better without the mic. Now I can hear myself speak. It's like weirder. So this demo sounds a lot more complicated than it actually is. It's actually quite simply built out. Okay, so first we're going to talk a little bit about the benefits of generative AI on streaming data. So some of these concepts may or may not be new to you guys, but I'm still going to go over everything just because that's what I'm supposed to do. No child left behind kind of thing, you know? I don't know if people get that or not, but it doesn't matter. Okay, so generative AI is a type of artificial intelligence that creates new data. Now, streaming analytics is the process of analyzing the data as it's being generated. So it kind of makes sense how they work together, right? So some of the benefits of using generative AI in streaming analytics is you have the ability to generate synthetic data for training and testing machine learning models. You also have the ability to identify anomalies in streaming data and forecasting future events. Okay, sorry, I'm like doing both slides at the same time. Like, there is like no place for me. Oh, and there's also an empty bullet point down there at the bottom. That's why. Okay, so understanding stream processing. So what is stream processing? So it is a data processing approach that deals with continuously flowing data, right? So as you're pulling in data from any kind of streaming system, you can actually run transformations and queries on this data as you're bringing it in before you actually store it. That's kind of the idea of what stream processing is. There's what I just told you. It involves the real-time analysis, transformation, and computation of data as it arrives without the need to store it in like a traditional database, although you should do that too. And it's used to extract valuable insights, detect anomalies, trigger actions based on incoming data, all in like the most real time you can possibly get it. It's literally before you're storing it. Events happen, you're processing. Okay. Understanding stream processes. So the types of queries that you can run when you're doing stream processing is filtering is one that involves the selection of like specific data from a stream based on predefined conditions. I thought it was on the screen, sorry. So the example is like filtering out log entries that contain errors for like immediate attention. Then you have aggregation, which involves summarizing or reducing the data over a certain window or key. So example, like you're calculating the average temperature over the last 10 minutes for a sensor stream. And then you have the ability for joining streams where you're combining data from multiple streams based on a common key or condition. Which is, yeah, so this is actually like one of the examples the demo that we're showing is like you combine user click data with product data to analyze user behavior. That's like an example of like joining streams. You can join a lot of streams. You can join dozens of streams. I don't have like a lot of use cases for joining dozens of streams, but you can do it. Another example is windowing. This queries group data into fixed time intervals or windows for analysis. I feel like a lot of these are kind of self-explanatory, like windowing. You're like, oh, maybe I kind of get it. Like analyzing total sales for each hour of the day over a week's worth of time, right? So like you create a window for that. Another one is pattern recognition. It's identifying specific sequences or patterns of events in the stream. Again, very straightforward pattern recognition. Like detecting a series of login failures as a security breach attempt. And then stateful processing maintains state information to analyze data over time, such as tracking user sessions. So monitoring user behavior and detecting when a user session is idle. Okay. And talk a little bit about rising wave. So let's see. Has anyone heard of rising wave? Okay, some people, two people. Okay, so rising wave is an open source distributed SQL database for stream processing. So I'm going to explain kind of like the features. I'll talk a little bit about the architecture. You kind of understand it a little better. But the things to kind of take note of is like Stream processing, it's all based in SQL. It's a database. It's open source and it's distributed. It's also built in Rust, which I think is great. So some of the features that it's built out for is it's designed to reduce the complexity and cost of building real-time applications. So it consumes streaming data from any kind of streaming source, like Kafka, Pulsar, Kinesis. And then you can perform incremental computation. So when the new data comes in, the updates results dynamically, that's like kind of where we're talking about, like the stream processing side of things. And then it is also a database, so you do have the downstream capabilities there, where it maintains the results on its own storage, so then users can access the data pretty quickly after they store it in. So you have the ability to query the data as it's coming in, or query it once like you store it. As I mentioned, it's like SQL-based and it's Postgres compatible, so it's like pretty easy to use. If you know SQL, you can use it. And it also separates the storage and the computation, so you can scale them out independently, which is also really nice. And it also offers you the ability to have incremental updates on materialized views, which is also like a pretty cool thing. Okay. So just talking a little bit about the data stream process in Rising Wave. Okay. So as I mentioned, like Rising Wave accepts data from sources like streaming sources, like Kafka, Pulsar, Kinesis, whatever, and then Red Panda, I should also mention that one because I have friends there, and materialized CDC sources. And then you can, sorry, I'm like, I have to like read this too. I'm like, what did I put down? Okay, so you basically can run the transformations and queries on the data as the streams are coming in, and then you can put it in output to an external database or a data warehouse or whatever, or like use the Rising Wave database if you'd like it to as well. But the processing thing in the middle, I think, is like kind of where the real powerful part is in like the stream processing of what your capabilities are. Okay. So we're going to talk a little bit about some use cases. So streaming into ETL is basically the practice of continuously extracting, transforming, and moving data amongst different systems. So extracting, like it supports ingesting data from a wide range of data sources. Transforming, it allows you to do all sorts of data transformations and queries. And then load, you can sync the process data from Rising Wave to downstream systems. You can actually put the process data back into a stream too if you want to, and just keep going in a loop-de-loop, but that's probably not very efficient. I just think it's funny to just think about. Okay, another example is real-time analytics. You guys are probably pretty familiar with it. It's kind of like a hot topic now, and it's been for years. Oh, that was good. That was good. It's all our pun jokes. You get it? The topic? Kafka? Yes, yes. Thank you. Thank you for catching that, because at first it took me a second too. That was a good one, Joe. That was good. See, you could be a comedian, especially if like you did it like to this audience. Like I think it would take everybody like a couple seconds to get it though. So you'd be sitting up here silently for every joke. It took me a second, and then but it doesn't matter. Anyway, real-time analytics is the practice of analyzing data as it's generated rather than after the fact. So it's really just the ability of being able to, I mean, I feel like I don't really have to describe it. It's analytics that's real time. And the business value, I mean, there's a ton of business value. One of the things that I've been working in real-time analytics for a couple of years now, and one of the things that I thought was the most interesting is that people who productize real-time analytics, they do what's called actionable insights. So they find ways to provide their end users, whether it be like businesses or individuals or whatever, giving them the ability to take action upon seeing any kind of real-time behavior. And some of the examples of it is like, if you have like a delivery app or something like that, and the restaurant's out of something, you need your users to be able to find out things right away, right? Or like grocery substitutions, whatever, like all those things need to be in real time. And then effectively, if you're giving your end user the ability to take action as soon as something happens immediately, you can also increase the happiness level of your users, potentially keep them on whatever kind of platform you have longer. Things like LinkedIn, they use like real-time analytics systems to do like who viewed my profile. If I'm looking at who viewed my profile, I want to know right this very second who viewed my profile, you know? I don't want to wait a minute or even a couple seconds. I'm like very impatient. So in many industries, it can provide a competitive advantage by enabling businesses to respond quickly to changing market conditions. That's also like the ability to use real-time analytics internally. And can be used to improve operational efficiency and reduce costs. So then there's like event-driven applications. So enables continuous event ingestion and processing. So if you're running queries on data as it's coming in, you can run queries on that data before you store it, or you can put it back into a stream, or kind of both, really. It also maintains context across multiple events and performs sophisticated processing. Detects complex patterns or correlations with a stream of events, and can provide direct integration with a variety of upstream and downstream systems. Let me see what my next slide is. Okay, so just to talk a little bit about the architecture, because everyone loves this part. So it has these key components. Pretty simple. It has a serving layer, basically parses SQL queries and then performs planning and optimization of query jobs. Then it has a processing layer that performs all the computation. Then there's a metadata management service that manages the metadata of different nodes and then coordinates operations among these nodes. And then there's a storage layer that stores and retrieves data from an object storage like S3. Okay, so implementing a use case, as I said, I can't show you the live example of this, but how this actually, this is a React app built on top of Rising Wave. But normally it's like you can like move across it and it updates in real time, and we actually tried it out and it actually is quite accurate, which is pretty cool. But this demo shows, this screenshot of a demo shows how you can use Rising Wave to do stream processing for real-time market data by taking account stock market values, and then how you can use NLP to enrich the daily tasks with GPT-4. Okay, so I'm going to show kind of like as I mentioned, it's all SQL-based, so like this kind of stuff should look pretty familiar if you know SQL, which I'm assuming most of you guys do. So in this case here, we're ingesting data with Kafka, connecting to Rising Wave. The code is big enough, right? You guys all see it? Okay, I can't zoom in, but I only have a clicker. I can either click in or out. I could just read it to you if you want. So with this code, we created a table accepting market feeds. And we did this by creating a Kafka sync data stream. Okay, then we created a materialized view that basically windows the market feed data. And we created the materialized view from the market feed Kafka topic. And this view is based on a window function that calculates the average mid-price for like a 5-minute window. And the query groups the data by symbol and then window start time and averages the volume, low and high prices for each group. Okay, and then we performed the streaming market statistics in 2 steps. First, we created a materialized view storing the price movement between the 1-hour shifted window and then the volume. And then we calculated the absolute difference between the mid-price of the current window and then the mid-price of the previous window. And then we grouped the data by symbol and calculated the move for each group. You got to share it with everyone. It sounds interesting. I don't know what it was. But okay. I feel like this is like such a fun crowd. Okay. And then the next thing we did is we performed stats aggregations over 24-hour windows. We calculated the standard deviation of the move in the volume columns and then the window end time. And then we grouped the data by symbol and window end time and selected the columns to include in the output. The result then is a materialized view that contains market statistics for each symbol and window end time that can be used for like analysis and prediction. Okay. Okay, and then we performed the streaming outlier detection in 2 steps. One is we created 2 materialized views that filter the symbols based on whether their price movement or trading volume has changed significantly. So outside of 2 over like the last 5 minutes. And then we did fully joined the previous views to get the symbols that either have outlier price movement, trade volume, or both. Okay. And then we defined a UDF that takes a stock symbol and an article and then returns some enriched data centered around a stock price indicator score and just a 1-sentence justification. So we created and added the UDF using Rising Wave's Python SDK. And then the function sends the prompt to OpenAI's API for the chat completion model. And then it receives a JSON response that includes a score, confidence, relevance, relevant similarity, justification, explicit mention, and keywords. I hope you guys can all see the code. If it's small, I'm sorry. I'm like really blind, so I can't see like anything from any distance. And like I don't know why I don't wear glasses. I just, I always forget them. I have them, I just don't wear them. And then we registered the function to Rising Wave. And then we joined the article metadata stream from a window 1 hour before and 1 hour after each symbol window by creating an enrichment table around market symbols. And then we did so by the following steps. So we created an enrichment table around our market symbols. And then we create a source for our newsfeed. And then joined our volatile symbols, our keyword enrichment table, and our newsfeed from 12 hours before and 12 hours after. And that's to like account for market closing. And then since calling the UDF is costly, we implemented deduplication responses from the previous API that can be retrieved from the Rising Wave cluster. And this way we reduce the number of times we called the API, reducing the overall latency of calling the UDFs. And then finally, we created the real-time streaming output containing both the enriched data updated in real time and the historical closed windows. And there's, again, the screenshot of the demo. So with this demo, we achieved the following. Big data analytics, complex streaming stats, aggregations over potentially 100,000 plus stock symbols. And we did so by reducing the cost of recomputation of intermediate and final outputs as new streaming data arrives. And then an expensive external API calls to ChatGPT via filtering and caching. And then that's it. And then the demo project was created by Jonathan at Rising Wave Labs. And then I had some help with my hype man, Joe. I told you that I had your voice slides. Yeah, and that's it. And yeah, I do have like a link to the blog. I don't know if I have a link to the actual project. I can like see if I could find it, but yeah. But thanks, guys. Thanks for coming.
Anyone? Questions? Questions, anyone?
Okay. We got one question. I had a question.
Madam, when you are creating this end result,